For this video, we're going to look at end behavior, which is covered in section 2.1. So end behavior describes what happens to the function values as x approaches positive and negative infinity. So function values meaning our y values. And so when we write end behavior, we write it like this, whereas x approaches negative infinity, y approaches something. And as x approaches positive infinity, y approaches something. So this negative infinity with x represents the left side of the graph. So when I'm looking at identifying end behavior as x approaches negative infinity, is saying on the left, y is going, and then it's either up or down. So we're going to write positive infinity if it's going up, or negative infinity if it's going down. And so this is all dictated by the degree of the function and the leading coefficient. And so we have two different types of degrees that we're looking at. So we can either have an odd degree or an even degree. So if the degree is odd, our arrows point in opposite directions. So some examples here are f of x equals x, f of x equals g of x equals 0.5x cubed, ... and then a power of 5. And so notice that the arrows on the left point down, the arrows on the right point up for this with a positive leading coefficient. And then it's the opposite when the leading coefficient is negative. So we're looking at whether the degree is odd or even, and then the leading coefficient is either positive or it's negative. And so we're comparing those two things so that we really have 4 different situations to look at. So when looking at those 4 different situations, the first idea of end behavior is as x approaches negative infinity, what is y doing? So let's look at an odd degree with a positive leading coefficient. Notice each of these graphs on the left, the arrows are pointing down, which means that the blank is going to be negative infinity. Okay, so as x approaches negative infinity, y is also going to approach negative infinity. When I have an even degree with the positive leading coefficient, notice that all of these graphs, the left side is pointing up. And that's going to be true for any even degree with the positive leading coefficient, that the end behavior on the left is going to be approaching positive infinity because the graph is pointing up. If we have something with an odd degree and a negative leading coefficient, notice the left side of all these graphs are pointing up. And so that means that the end behavior is going to be approaching infinity. So the values are getting larger on the left, versus if I have an even degree with a negative leading coefficient, all of the graphs are pointing down on the left, which means the end behavior as x approaches negative infinity is that y is also approaching negative infinity. Okay, so dependent upon the degree, I know that we've only given you 3 examples here, right? So a degree of 1, a degree of 3, a degree of 5, and then a 2, a 4, and a 6. And so know that this is true for any even and any odd degree, that the graph's arrows will point in those directions. So then after looking at the left side of the graph, we want to also look at the right side. So the statement as x approaches infinity is saying on the right side of the graph, y approaches is saying the arrows are pointing which direction. And so for an odd degree with a positive leading coefficient, notice all 3 graphs are pointing up on the right. So that means the end behavior on the right would be positive infinity. So that this blank here would be positive infinity. For an even degree with a positive leading coefficient, the graph is also pointing up on the right. And so that end behavior as x approaches infinity is that y is also approaching infinity. Finally, when I have a negative leading coefficient, if my degree is odd, notice all the arrows are pointing down. So that means the right side end behavior is going to be approaching negative infinity. Last, for an even degree with a negative leading coefficient, notice that all of the arrows again, are pointing down. And so this, as x approaches positive infinity, y is going to be approaching negative infinity. And so each of these patterns are true for any function that is an odd degree or an even degree with a positive or a negative leading coefficient. So really, these are 4 different situations that students need to memorize in order to identify end behavior. And so one of the ways to help yourself memorize them is to think about the most common or the most basic functions of odd degree, which are lines. So if the leading coefficient on a line is positive, think about it like a positive slope. And so that helps memorize how the arrows are supposed to point. Same thing with a quadratic. So if you remember what a parabola looks like, if A is positive, then that helps remember that the arrows always point up for that situation and down for the other if the leading coefficient's negative. Another way is to just memorize the first 2. So when it has a positive leading coefficient, and then to know that it just switches if there's a negative leading coefficient. So whatever strategies you need to use to help yourself remember each of these 4 different situations, you have to know them in order to identify end behavior on a problem. So let's practice that with this example. So in this, we have a polynomial and we want to know the end behavior. In order to find end behavior, we have to know the standard form of the function to identify the degree and the leading coefficient, because the degree and the leading coefficient tell us how end behavior should look. And so what we want to do is take the equation they give us and write it in standard form. So for these, notice there's no like terms, there's no powers that are the same. So we're just organizing the powers so that it goes from greatest to smallest. So that means our function for f of x is going to be negative 9x to the 6th minus 5x to the 4th plus 7x to the 3rd, and then minus x. And so in order to answer this question, we really just have to look at the first term, because that term tells us the degree. So the degree, this power is, the highest power is 6. That's an even number. Sorry, that's an even number. And the leading coefficient is negative 9. Again, I care that that is a negative number. Okay, so once I have these patterns memorized, I'm just thinking about what it is. Right now, we'll refer back to the table. So if I have an even power and a negative leading coefficient, the end behavior is going to look like this one here. So it's going to be going down on the left and going down on the right. Okay, so it's pointing down on the left and down on the right, which means that as x approaches negative infinity, right, this represents the left, y is also approaching negative infinity. And then as x approaches positive infinity, which is the right, y is approaching negative infinity. Okay, so this statement is the answer to the question. I just needed standard form in the degree and the leading coefficient to answer it. So one thing to notice is that with standard form, all that I cared about was the first term. So I don't necessarily have to find standard form. I really just need to find the first term. So looking at this problem, the highest power is a 5th power. So that means 7x to the 5th is the first term, which tells us that the degree is 5 and that the leading coefficient is 7. So we have an odd degree and a positive leading coefficient. So looking at the table, an odd degree and a positive leading coefficient tell us that it's pointing down on the left and up on the right. And so that means that as x approaches negative infinity on the left, the graph is approaching negative infinity, and that as x approaches positive infinity on the right, y approaches positive infinity. So that's the end behavior when we have an odd degree and a positive leading coefficient. Okay. And so if, for example, we had A, the opposite sign, so if it was a positive leading coefficient, our answers would change by the sign would switch. Same thing with B. So if I had an odd degree with a negative leading coefficient, the first one would be positive and the second one would be negative. So you really just have to work on memorizing how the patterns work, and then end behavior is just analyzing degree and leading coefficient in that way.